Hello everyone! Welcome to this installation of Getting Started with MESA. So we're going to walk through what is on the web page, and I understand you can't just read it on the web page, but different people have different learning modalities, and I've certainly followed along on a video or two, particularly with like Adobe Illustrator, to learn how to do various things. So there can be advantages to having a different modality to it as well. Plus, I'm probably liable to say things that are not on the Getting Started page here, and there will be things that I won't say that are on the Getting Started page here, so it's a little extra and auxiliary information. So let's get started. I'm going to assume that you have MESA installed. In particular, I'm going to be working with the latest public release as of September 28th, 2020, so this will be version 12.778. And we're going to get MESA up and rolling. Okay, so there's a little whirlwind tour there. So over here, you can see I've set my MESA dir directory to 12.778, and I'm in my MESA work directory. This is where I do all of my work. You should make a habit of not running necessarily in the test suite directory, which we'll get to, but having your own work area where you do all of your MESA work. So we're going to head and do a cut and paste. So I'm going to do it here. I'm going to copy MESA dir star work tutorial to tutorial. There we go. So I'm going to cd tutorial. And what do we got in here? So this is sort of a very standard MESA directory. The ones we're going to be concerned about mostly today are these things called inlists. This is where you direct MESA to do what it's going to do. There are a couple of scripts, these things with stars, and they're just plain scripts. There's a clean, there's a make, there's a restart, there's a run, there's a source directory where if you wanted to, you could put stuff into a run star extras to modify how you want to do particular things like a wind or convection or opacity or what have you. And then there are two directories, logs. This is one of the directories where MESA will by default put its output, profiles, time history, etc. And then there's the photos directory, which we'll get to, and this is where it stores essentially binary checkpoints. So if you want to restart a calculation, which we will be doing, those are going to be stored in photos. Okay, so we have successfully copied it over into something called tutorial, and we are in tutorial. So let's go ahead and do a /make. /make. And voila. And so what has changed? So what has changed is now we actually have an executable, something that will run. And this is what the script rn will do. So like I said, it's just a plain old script. You can modify it if one so desires. I'll do it more. Right, and so it's just going to remove any restart photo that happened to be there, and it's just going to run star, and it'll put the dates out before and after. Okay. So we have made a copy of the star work directory, we've made the executable, and now we're going to look at the inlists. Okay, so let's go over here. So I'm going to use Emacs as my editor. You're free to use any editor you like, and I'm going to use Emacs. So the first thing we need to do is look at the inlist. And so you can see that there are three sections. These are actually Fortran name lists. So we got star job, control, and PG star. And it's going to read an extra star job inlist. And that file is called inlist project. We're going to read an extra controls inlist project, and we're going to read an inlist PG star. Now, of course, you don't have to do it this way. You could put all your MESA commands inside here and just run inlist. That's perfectly fine. But there are some advantages to breaking it up into different inlists. So we're going to take a look at inlist project, since that's the main one that is going to be read. And so here's our job we're going to run. So we're going to start off by making a pre-main sequence model. We're not going to save a file right now when it terminates, so we're just going to start with a pre-main sequence model. We are going to put up some plots, PG star, and we're going to run a 15 solar mass model. By default, metal is going to be roughly solar metallicity. A couple of MESA settings on the type of energy equation to use and how accurately to solve them. That's the gold tolerances. And most important for here is when to stop. So we have two stopping conditions here. One is when it stops near ZAMs, 0H mean sequence. So one definition of that is when the nuclear luminosity divided by the total luminosity is about 99%. So nuclear is carrying most of the luminosity. We also have a secondary stopping condition here that we'll get to, and this is when the central hydrogen abundance has dropped below 10 to the minus 3. In other words, all the hydrogen in the core has been burned to helium. And so those are our two stopping conditions. We'll obviously hit ZAMs first. Okay, so that's what this does here. It walks you through a little bit inlist and then inlist project. Oh, and we might as well take a look at one of my favorites, PG star. So let's go ahead and look at PG star. We have a whole. So this is what MESA uses when it plots live. So these are the two types of plots. There are many types of plots, but these are the two we're going to be looking at here. One is an HR diagram, Hertzsprung-Russell diagram, and so it's setting the x-axis, Tmin, Tmax, luminosity min, luminosity max. The size of the window is going to be 6. You can change that if you like. And then it's also going to be putting up a profile. So we'll be able to take a look at what the total model is doing from the core to the envelope. We have an entire PG star tutorial that is going to be much more involved. I encourage you to take a look at that. We'll put a link to that in the video down below. Here we're going to change that window width. So it's going to put up two plots as we go. We're going to go back to project. All right, and so we've taken a look at inlist project, and now we are ready to run MESA. So you're just going to invoke that script, rn, and it will begin to run MESA. So the first thing it's going to do is it's going to read some equation of state stuff. That's at EOS dt, and away it's rolling. Yep, that's what took a little while. We had to get our X windows up and going. So now it's flying along. So here's our two plots. There's our HR diagram, and there's our central row profile. There's various demarcations here where hydrogen begins to burn, helium, carbon, extra. This is where the radiation and the gas pressure is approximately equal. This is basically a degeneracy line where the Fermi energy over KT is roughly about 4. And then various properties of the model as it goes. So there's lots of terminal output flying by here. So why don't we go ahead and take a look at one. So it tells you the step number it's on. So as it runs across, you've got these 1, 2, 3, 4, 5, 6, 7, 8, about 30 odd, 40 odd quantities. So the step number, the time step in years, the age in years, what the central temperature is, what the outer temperature is, the effective temperature, the luminosity from hydrogen burning. There's no triple alpha, so minus 99 means none. And then over here is what is controlling the time steps. There's lots of information here just from the terminal without necessarily having to throw up plots. You can just see what's going on if you like lots of numbers being thrown at you. Personally, I find plots to be a little bit easier. So this thing is running away. Where are we at? We're about 6:04. Let's take a look at our plots. So we're coming down the pre-main sequence track. And where my other window went. There we go. So you can see it's crawling up. This is the profile, temperature versus density. This is the outer part of the star. This is the center of the star. We've crossed the hydrogen burning line, so we burnt some hydrogen until we got to the end, which at step number 943. And the reason it stopped is in the termination code. the nuclear luminosity divided by LZAMs, we've reached the limit that we set of 99%, and so that run is done. So it's fairly quick. Nice, so it puts up the plots that we were just looking at. It should run for about 940, so we got 943, and then it stopped as we did. And there may be times when you want to restart MESA. So you started from the pre-main sequence, we ran it to ZAMs, and what if I wanted to run it to the end of core hydrogen burning? Do I have to start all the way from the beginning? No. You restart it up from what is known as a photo. So let's go ahead and take a look at that. So here's our ls of our directory, and now let's see what's in that photos directory. So these are binary dump files. They are specific to your machine, your compiler, so you can't share them. They're just for you, but they contain a snapshot of the state of the calculation, and you can pick any one of these and restart it again, and that's what we're going to do. So here's our ending step, 943, so X943 here corresponds with this number right here. So that's where this one ended at ZAMs, and so we want to pick up the calculation and carry it on to core hydrogen depletion. Okay. So the first thing we need to do is change our stopping condition, because if we just fire it up again from the photo, we've already reached ZAM, so it'll just not do anything and stop. So we don't want that. So I'm going to comment this out. And now our stopping condition is that the central hydrogen abundance goes below 10 to the minus 3. Okay, so I've changed that condition. And now to restart from a photo, it's /re for restart, and then in 12778, you give it the name of the photo, 943, so it knows to go and look in the photos directory, and it will pick up this file right here, and we will go. Boom. So MESA's running, it picked it up. Here's our two windows back. There's our HR diagram. Here is our profile. And it wrote out a few more things. Let's see if we can pick up the hydrogen abundance. So I'll just stop it right here, take a look at it here. So if I was curious what it was doing, we have at the center, we have H center, and the calculation stopped. So here we've already passed ZAMs. The mass fraction for the hydrogen in the center is 0.39. And it will go down as time goes on. Now it's 0.17. As time goes down, it's 0.05. Hydrogen in the center is 007, James Bond. And finally, it gets below our tolerance, which is 10 to the minus 3. So now it's 90 minus 4. And so we have burned all the hydrogen in the core. And that was from a restart. Okay. So if you'd like to learn how to save those plots, those PG star plots as it goes along. Again, I'm going to encourage you to take a look at the PG star tutorial on how to do that and much more with PG star. Okay, so we did this. We stopped near the ZAMs. We did a restart. Now, there can be times when you don't necessarily want a binary photo restart dump, but you want a text file. And the advantages of the text file, although it's not exactly the same as a photo, it can be shared because it's a plain ASCII photo. So for example, if you're running into a problem and you want to share the model with MESA developers, you would share the .mod file, or if you're working in a collaboration and different people are on different machines and you want to share particular aspects of it, you can share that .mod file, and people will be able to start up from that .mod file. So we're going to go ahead and do that. So the first thing we need to do is save a mod file. So we're going to go back to our inlist here, and we're going to start it up again. We're just going to rerun from ZAMs to hydrogen depletion, except this time we're going to save a .mod file. So I got that, and now do an ls, no mod file, and so I'm just going to rerun, start up from XAMPP again. That goes fairly quickly. So we'll refire it back up. Boom, boom, there's our plots again. Our lovely HR diagram and our T-row profile. Many, many types of plots you can do with MESA. These are just two in separate windows. So it's zipping along there, and hydrogen is going down, 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 and boom, done, stop. Very good. And so now if you look, you can see that there's this file that we said to create, 15M Sonnet TAMS. We gave it that name. Here's our inlist. We said save it to this name, so that's what we got. And you can take a look at it if you want. It's just a plain text file. And so this tells you a little bit about the model. LND is the log of the density, the log of the temperature, log of the radius, the luminosity, photon luminosity, how much, the fraction of the star that is in a given cell, and then various other quantities that you can take a look at, helium abundance, so on. And so this is sufficient for somebody on another machine or MESA dev to refire the job up. Personally, when I'm running by myself, I prefer to start up photos because photos will give bit for bit startup again. Mod, pretty close, but not necessarily exact. And so I encourage using photos in your own work if you're going to be restarting rather than mod files. That's a personal preference, but there it is. Okay, so we restarted, we saved the model, .tams. We did it a little differently than that, but that's all good. Okay, so there are lots of things in here, like how you set the mass, how you set various things, and so how do you know where these are? And so these live in a directory called $mesadir star defaults. Oops, ls. Okay, and you can see there's lots of defaults. There's a controls, there's history columns, PG star defaults, star jobs, and so we can just go ahead and take a look at one of those. Let's take a look at controls. Okay. And so these are things that you can then put in your inlists. We did things like the initial mass. You can change the initial Z. If you don't specify something like what we just did, then it picks up the default value, which is 0.02, which is solar-ish, let's say. Initial helium abundance, controls for the output, how often you want stuff coming out. There's a whole bunch of stuff in here. So I really encourage you to take your time to go ahead and walk through what is in these default files, particularly you want to start changing default behavior, which oftentimes you probably will. Okay. So in the website, they walk through, okay, if you want to learn something a little bit about different mass losses, Dutch winds, low T winds, so you can go ahead and see what the settings are for different types of winds. Now this was the tutorial. There's lots of other things that one could learn from and probably should learn from. So one is in the test suite itself. So let's take a look at what's in there. Ooh, lots of stuff in this test suite. Lots of examples of things to run, and you're free to use any of these as examples. They are built for the test suite, so meaning that they're designed to run relatively quickly, not something with a great deal of mass resolution or time resolution. And so if you're going to be taking those and envision doing science with them, then you're going to be want to changing those parameters and others, because again, this is designed for a test suite execution, an overnight test suite execution every night. Several machines run this, but it's not necessarily the best for a publication quality piece of science. So you want to make sure we do that. So let's go ahead and take a look at one. There's a few little doodads you have to do when you do that. Here it gives you an example of running it inside the test suite. I tend to avoid that. I like keeping my MESAdir clean. So let's go ahead and make a copy of high mass. So where are we? So we're going to go back and we're going to copy the high mass test case into something called my high mass. Okay, so let's go ahead and do that, and now we're going to cd to my high mass. Okay, again, it's a fairly standard MESA work directory. We can see our inlists, we can see our scripts run, our source directory, our logs file, photos, where the binaries will go, data files will go in logs. And so we want to go ahead and run this, but because we pulled it from the test suite, there's a few little extra things you have to do when you pull from the test suite. The first thing we need to do is edit the make file and take out the MESA dir, because this is specific to the test suite. So I believe we go into make, and let's go ahead and emacs make file. Okay, and so you can comment this out or delete it. I'll just delete it since we pulled it out of the test suite. Okay, so that takes care of that. Now we're back in our my high mass case, and there's going to be other instances of this MESA dir, so let's go ahead and just find those. So look here for the name MESA dir in all files. Okay, what did I do wrong there? Okay. Let's just say inlist star rats. What am I doing wrong here? Find dot minus name MESA dir inlist. Editing in real life. Let's just go in there. Enlist. That all looks fine. There we go. Enlist high mass header. And start header. So that's where the two they are. So we're going to edit enlist high mass header. There's that MESA dir, which we need to get rid of. Just comment it out. And the other one was in start. Header. There it is again. Boom. Okay. So we got rid of those two. Now we can make. So we create the executable. So this is from the test suite. And now we're going to execute an RN. And so we're running away here. It's loading some EOS files, compressing the bin files into the MESA tables, into the MESA EOS. And so away it goes. It's going to do two things in this one, which is interesting. It's going to relax the mass, I believe up to 100, 110, and it's going to relax the metallicity. So just examples of how to relax mass to something different than what you start with, and how to relax the metallicity to something different than what you have with. And I'll just leave that as it is as examples. So we did that. And there we go. And we have completed this getting started tutorial. There's no plots in this one, again, because it's built for a test suite, not necessarily as a tutorial. But of course you could add any of the plots that you want. So it finished relaxation number 1, it finished relaxation number 2, and away it's going, and it's saving logs. Those are the profiles and histories and data files. Okay, so that's going to do for this one. This was our walkthrough on getting started, and I hope you found that useful, and we'll see you on the next one. Bye-bye.